A thumbs up.
All right. Okay, it's 3:30. We're going to get going. Welcome everybody to app packaging and deployment for the Windows Universal Platform. My name is Barclay Hill. I'm the program manager lead for App Platform, specifically the deployment area. And with me is Jason. Hi. Jason actually owns core deployment on my team. So our team is actually responsible for basically all the verbs with apps. So if you're installing an app from the store, running an MSI, installing an app through our enterprise kind of scenarios, MDM, basically all verbs related to an app, packaging it, working with it under Visual Studio, those types of scenarios, that's all our team. I'm supposed to remind everybody to please fill out an evaluation, and please do. We have a friendly competition going within the app model, where we're fairly competitive. And so tell us what you like, tell us what you didn't like, what you're hoping we would talk about, and we'd like to see the feedback. So this is kind of a model map of the sessions that App Model presented here at the Build conference, as well as one session coming up at the Ignite conference. You're here, they call us store because it's store apps, right? But basically we're going to be talking about packaging and deployment fundamentals, and specifically what's new in Windows 10. As you can see is that, so my boss, Andrew Klinick, who presented kind of the lap around App Model, he presented on the first day. I would actually suggest you taking a look at that. That was a good high-level overview of everything that's new that's coming from the App Model. What's left still in the week is app services and shell integration, which is Friday. Please take a look at that. So specifically what we're going to be covering today is benefits of universal Windows app packages and deployment. Specifically diving deep into kind of the packaging and deployment from a developer perspective, looking at what it looks like locally, and kind of reviewing what's new with Windows 10 in that respect. We're also going to cover app storage improvements, getting more app with less space, and the continued support for down-level packages or previous platform version packages. And then at the end, I'll wrap it up. But before we dive into this, how many folks in the audience attended our session last year? Anybody? Couple. How many folks have an app in the store or have built a modern app? Oh, wow, fair amount. And for phone? Cool. And for desktop? Oh, that's pretty good mix. Okay. All right, so at this juncture, I'll turn it over to Jason to cover the benefits.
Thanks, Barclay. So like Barclay mentioned, my name is Jason Salome. I am the program manager on the Windows, what are we calling it, App Model core deployment team. And so I own the verbs install, update, remove, etc. If you went to Andrew Klinick's talk on Wednesday, he mentioned kind of this cradle to grave model, and he had install, update, and remove there. So those are the kind of three that I own. And so the things that we wanted to talk about today here was basically kind of taking a step back and really looking at the benefits of why should you go and build a universal Windows app. And what we've done is we basically broken it down into three pillars. And the most important thing is that these things are still AppX packages. Is that we introduced this in Windows 8, we've improved on it in Windows 8.1, and here we are again continuing to improve on the story. And so we've broken down the story into three basic pillars. The first one is all about easy deployment. Again, you heard Andrew talk about this yesterday, but when you're installing Win32 apps from the olden days, they were rough to install, they take some time, you got to click through all these dialogues, you have to build the installer yourself, you have to build the updating model, you have to figure out internet connection, no internet connection, you have to do reboots, et cetera. It's kind of a painful and really, I'd say fragile story. And the worst part about it is when the app is removed, oftentimes a lot of kind of CRUD is left over on the system, and this causes the PC to slow down. It causes problems over the life of kind of the device. And so with AppX and kind of with these universal Windows apps, we really provide a clean way that's safe to install these packages, seamless updates, no reboots, and then a clean uninstall. So the next kind of pillar that we wanted to talk about is the declaration story, kind of the way that we express to the system what the package or the app is intending to do. And this is done via the manifest. So Barclay will do a little bit of a deep dive in the manifest a bit later, but the manifest provides the package and the system with a powerful way of kind of expressing what it wants to do to the system. Example, extensions or registrations, et cetera. We have the formal versioning model that tells us how we update. And then we finally, another good point is being able to target particular device families. Again, Barclay will talk about that more a little bit later. And the last one, which I'm really, really psyched about, is basically all the space savings that you get when you have these types of apps. And this breaks down into 3 buckets, and we're going to talk about these in more depth right now. The first one is incremental updates, which is basically moving from V1 to V2, the space savings that you get if there's things that haven't changed from the old version to the new version. The second one is file single instancing. It's this very similar concept, but across packages that come from the Windows Store or have the same kind of origin. And the last one is about partial resource downloads. And these are for all app developers that have multilingual or apps that are targeting like these very large-scale devices or small-scale or all-scale devices. We want to make sure that the Windows Phone device isn't having to download resources for, like, say, the Xbox or the PC or et cetera. So let's dive in a little bit deeper. For incremental updates, the way this works is actually pretty simple. We have kind of a 2-phase model. And the first phase, let's say we're going to update to app version 2. The first optimization that we provide these apps is basically a file level optimization. If there's a file that hasn't changed between version 1 and version 2, well, there's no reason to go download it again. There's actually no reason to go and use that bandwidth and that time. So what we do is we end up creating a shared version of that file that can be used between those two. Obviously, the old version will eventually be removed, but until it's removed, the file is basically shared between those two. The second type of optimization that we provide is on a block level. So we have a piece of metadata that lives in the package. It's called a block map. You can go and crack open an AppX package and see it. It basically has 64 kilobyte compressed representations in hash of the file itself. And what that allows us to do is it allows us to uniquely identify blocks within a file. And if we see that, hey, there's blocks here that are identical between the old version and the new version, well, there's also no reason to re-download those again. We simply copy them over, and then the files for the blocks that are not equal, those get re-downloaded from the store. So it's a very clean model, and you see here what ends up getting downloaded is 3 blocks in this example. Now, to kind of take a step back and look at this in the more holistic picture, when we think about like on a Windows phone or on a desktop PC or Xbox, when you want to go and download an update, it takes so much time. Like I've seen devices in the past where I want to download an update for a game or say an app, and the update is like 50 or 60 megs, and I'm like, what's going on here? Why is this so big? And then it's like bug fixes or something in the subnotes, and it's one of those things where it's like I don't understand, but it's really like this is one of the really big benefits that I think we get as far as updating on mobile. So the next thing that I want to talk about is bridging that from the within the same app to the multiple apps. In this case, I have an example. I have 2 Windows Store apps, Mahjong and Solitaire. And for the sake of the example, I use these 2 because they're by Microsoft, but this doesn't apply to apps within the same publisher. Let's say I download Microsoft Mahjong. It's got an ad platform, a game, and then some files. Then I want to go and I want to download Solitaire. So we notice, hey, Solitaire has an ad platform and the same game engine as well. So instead of downloading those files again, let's actually go and create a shared copy that can be used between those 2 apps. Finally, we download the rest of the files. Now, the next question that we always get is, well, hey, what about an update? What happens if one of them changes? As you'd expect, in this case, if the game engine changed, we would re-download that game engine for the new file. Hopefully this doesn't happen, and then the file would no longer be shared between those 2. So we preserve everything, and the best part is that it's totally free. It's like you don't have to do any extra work. There's no extra coding. You don't have to do any checks or anything. The practices that we have in place is basically we say, if you're using a third-party binary or library or component, that's a common one, just don't recompile it, don't change it. If you have multiple apps in the store and you have a shared library, make sure it's updated and the same one across all of them, and then you'll be able to reap those benefits as well, which is great. The last optimization that I wanted to talk about is partial resource downloads. We've heard a lot in the keynote is that we want to have these universal Windows apps that scale from small screens to big screens, everything in the middle, and sometimes even like HoloLens, no screen at all. And so we're starting to see a reason to have like a lot of scales or a lot of languages if you have a multilingual app. One of the things that we did with Universal Windows Apps is if you have an app that targets multiple devices, when you have that app and you're building all those scale assets, instead of going and downloading every single one of those assets on every single device, we make sure that we acquire only the ones that are needed for that device. And the space savings that we've actually seen is on the order of sometimes upwards of 15% to 25%, depending on the scale assets. Obviously, this is a game, and there's a DirectX asset. We're talking many gigabytes, especially for these larger apps that are going to start coming down pretty soon. So to recap, the benefits of Universal, it's really basically 3 points. It's these predictable and successful deployments, clean install, easy updates, no reboots, and rot-free removals. We don't have PCs being slowed down over time, and it's kind of all these benefits that we get. The next one is the declarations as part of the manifest. You have the ability to do a lot of things in that manifest, which Barclay will show you a little bit later. And it's a very, very easy way to declare all that in a XML format. And basically, the system understands that and is able to do all those things for you. And then during an uninstall or during a cleanup, we're able to exactly mirror the removal of those operations. And the last one is these noteworthy bandwidth and storage savings, which I just talked about. So with that, I will hand it over back to Barclay, and he's going to tell you a little bit about universal app deployment.
Thanks, Jason. All right, so universal Windows app deployment. So we're continuing with our approach that we've used in 8.1 for phone and also desktop. The previous versions of the package artifacts still fully supported. There's no stopping any of the support for anything that's actually been published in the store for Windows 10 devices. We'll take a look at the manifest as exactly how this is enabled. So essentially is that if you're working on an app and have an app in the store and you want to move to a universal app, if it's a Silverlight app on the phone, we do a full migration, meaning that we go ahead and upgrade it for the user experience of the user of the device. They don't see any difference. They think it's just a simple app update. But effectively, what we're actually doing is doing a migration underneath the covers when we move from Silverlight to a universal app and pull the state that the app wrote previously over to the new app. Any of the serialization format and upgrades you would do in the context of your app, of course, you would do it at launch time, or you could actually implement an upgrade task. We support an upgrade task, and this allows you to do any of that data manipulation or re-register for push notifications and whatnot, so your tiles don't go dark. They can continue to refresh. What's new in Windows 10, we're introducing device family targeting. Previously in the manifest, we were somewhat limited. If you look at Silverlight for phone, there's really just a platform version in there. So it was basically 7, 7.8, 8, and 8.1. And apps really just targeted that major and minor version of the platform. So there really wasn't a whole lot of ability to take advantage of new features that would ship in an incremental update. And typically the app model only revved at a minor revving, and that could have been sometime in between releases. Now you have the ability to actually target down to an OS build. And so as you can see is that we're releasing much more frequently, and we're releasing new features. You can expect is you could actually build updates to your app to take advantage of those specific apps or those features that we're going to introduce. And one area we've spent a lot of time on improving, and I'll demo in a minute, is reducing the friction in the developer unlock experience. We've gotten a lot of feedback. I've gotten a lot of emails. Hey, why when I fire up Visual Studio, I see this dialogue? Has it really been 90 days? I swear I just saw this last week. Or, hey, I jumped on a plane, I had expected to work on my app, but I'm locked out. You know, it wanted me to renew my license. A lot of feedback about that, as well as feedback on mobile. Things like, well, I built an app, I want to share it with guys on my team or gals on my team, except they don't have the tools. So they have to download full Visual Studio and go in and lock their device, and you know, it was working, and then the device locked itself back. I'm not sure what's going on. So a fair amount of feedback actually came directly to me around this. So we spent some time actually improving that. And so how easy is it to unlock? Well, it's real easy. We'll take a look. We'll look at it. It's actually in settings now. You go into settings. We have a converged settings CPL that basically you can enable sideload or developer mode. And we'll talk about that more once we get into the demo. On desktop, effectively, well, desktop and mobile, effectively when you're actually doing this, what we're doing is we're writing some registry keys back to the OS. On desktop, you can actually change these yourself, if you're an admin, of course. On mobile, of course, it's a locked device. You can't write to the registry. But effectively, when you're entering in enabling sideload or developer mode, you're also enabling other services to run. So this is what it looks like on phone, so it's pretty consistent what this looks like on phone. Now, the difference between sideload apps and developer mode, when you don't have developer features enabled, basically all sideloading is blocked. Apps have to come from the store. They have to be signed by Microsoft, basically. If you enable sideloading of apps, basically you're enabling apps signed by authority that your device trusts. And that trust is defined by a code sign certificate that you add to your device. When you're in developer mode, you're actually going a little bit step further. You're allowing tools to integrate with the device. You're allowing debugger to deploy an app, loose file deployment and register it, attach a debugger, control some of the execution on the device, as well as other tools that we actually have. That last option, developer mode, what that actually also does is it starts services on the device. So as soon as you enable that mode, you have additional services running on the device that supports the developer tooling. So if you looked at what we actually had in 8.1 for both desktop and mobile, is basically we have the sideload option only. And just when if all you wanted to do is sideload a package, you were basically starting all the services whether or not you needed them or not. You just wanted to sideload a package. So no muss, no fuss, right? There are limitations, of course. Desktop, there is no cap on sideloaded apps. It's unlimited, sideload as many apps as you want. On mobile, it's capped still at the 20 sideloaded app limit. And so why don't we jump into the demo?
Yeah, you're good. You're good.
All right. Okay, so what I went ahead and did, I fired up Visual Studio because I didn't want you guys to wait on this. I pre-built the project because I didn't want you guys to sit through the template being created. The build that I'm actually running is not the build that was released this week. The build that was released this week, the developer mode options, is not fully enabled in that build, but it's actually coming very soon. So if I was to open my project, my Universal Windows application project, there's that familiar dialog, but it says something new. Instead of saying you need to acquire a developer license, it tells you go to settings and actually to enable it. And that's what I'm going to do right now. So I'm going to go to settings. You're going to find it under update and security, under for developers. And there's a link so you can jump off to MSDN and learn more about what these options actually do. Now, this CPL is, or this control panel, it's also can be controlled by the admin. So if the admin pushes down group policy to the device, like in our case within Microsoft, we're actually enabled. Everybody's enabled for developer mode, and it's actually deployed that way. Now, it could also be disabled. If it is disabled by the admin, you will not be able to turn it on here. But if you're a developer and actually have admin level privileges on your device, you can enable that. And so for the demo, as I'm going to And there's the dialog that kind of warns you about side loading. I'm going to enable it for developer mode. And so if I go back to the IDE, I can just dismiss it. So that dialog, if you've worked in Visual Studio in the past, it basically was on a scheduled task, and it was tied to the expiration of your developer certificate or your developer license. As long as you stay unlocked, you won't see this. But if you do go back into a locked state because you changed it yourself or if your admin changed it, you will see that dialog when you actually load your code. So why don't we take a look at the manifest? I've blown this up so you guys can read it back there. It's going to be very familiar to what people have seen before. I think every time I've demoed this, people go, wow, you guys are really proud of this XML document. We actually are. It's a declarative deployment artifact. It's really what helps us in deployment understand what we're going to do against the machine when we go to deploy the application. This is much, much different than MSI. We own the MSI technology as well. MSI, of course, is imperative. So it has a possibility through custom actions and whatnot to run code when the installer is going to run. So we do think that this is a big deal, and it presents lots of benefits. And it's also what helps us to have highly reliable app installs. So to take a look in this, one thing you might notice, we made the decision is that for Windows Universal Apps, starting with 10, this might not always stay this way, but for now, we're just going ahead and adding a phone identity element, this identity element here. This phone product ID primarily was the identifier we used when we actually had the separation of stores. We had the phone store, and then we had the desktop store. Now we have one store. Given that we have devices out there that will be upgraded from 8 to 8.1 to 10, the primary identifier for these apps that are already in the ecosystem is this phone ID. Now, when you create a project or the project that you have for your existing app, this GUID that you have has just been uniquely created at the time you created the project. When you submit it to the store checks to see if you're submitting as an update to an existing app, and they inject what the real product ID is. And so when the app update comes down, we use a combination of the product ID and the package family name. This identity that we actually use is defined here, as you can see. It's a combination of the product family name is a combination of the name of the package, the publisher, and so on. We also have a package full name that includes kind of the architecture, whether or not it's a bundle, and the version. And that's the strong identifier when you're not dealing with upgrades. But this phone product ID is what allows us to pull these actually together to perform these upgrades. The other new feature within this, and I'm actually going to make this fit. If you've ever looked at the manifest before and looked at the code behind the actual designer, you may have seen what we called app model version in the past. And this is something like for Windows 8.1, it was 6.3, and for Phone 8.1, it was 6.3.1. And that basically matched with a model version that we revved independently. So when we add features to the app model, we would actually rev this. This is what gives you the ability to actually target specific versions of the app model. Those app model versions really didn't change, but only when we did a major minor release would we actually do an increment, and unless we did a major, we wouldn't actually increase that number. The major number, as you could probably be aware of, it's actually more of a marketing number than an actual build incremented number, as I think we skipped some digits in there. But so that first number is basically a branding version number. The next number there is the minor number, which is 0 here. It's basically defaulting to what the SDK is pulling in. And of course, this is the build increment number, and this is the revision number. So what this allows you to do, as we crank on and we're going to add features, you can have apps out in the ecosystem, and you can actually take advantage for some of the users that have taken those updates to take advantage of those new app model features or new runtime features. This min version is what defines applicability of the package to the OS. So essentially what happens when you click the button in the store, lots of communication goes through the pipeline, but basically the store sends us down a string that's been captured at the point of ingestion. And we actually look at that, and it's a combination of this as well as a number of other factors, and we define its applicability to the OS. And that's what tells Windows Update and our download pipe to actually say, okay, go ahead and go get us the bits, this is applicable. Max version tested, won't get into too many details, but this actually defines the process space. So if you can actually increment that up to say, hey, I've tested through these different versions, but the max known version that the OS is aware of is what it would run it in that process space for compatibility reasons. So target device family, as you can see, is in the name. It's Windows.Universal. And that means any platform that supports or that's derived from the Universal App Platform that supports that would actually be able to run those apps if they have that version of that subsystem. You can also define multiples. As you might see also in this release of VS, there is no designer on it. That will come. Right now, you just get the XML. There is IntelliSense because it's backed by the XSD. I can define a new one and just say name Windows.Xbox. And of course, I would go through the min version and so on and define it as such. And this is kind of a hunt sequence. So basically what this would mean is I think the typical scenario is you'd want to actually build an adaptive app that would probably target all these devices. You want to increase your market potential as much as possible. But you could run into cases where the platform's rev that you want specific versions of platforms, right? And you'd say, well, the min level for Universal App, I would support this version, but these specific device families, I need this version. So you can do something that's even specific for, let's say, mobile, like this, or desktop. If I take Universal off of that, basically that makes that package applicable only to that target device family. Target device family because it's not just a desktop, as you can imagine. It could be anything that's running full Windows core, right? It's going to be a 2-in-1, a tablet, and so on. But for the sake of our demo, I'm going to leave it as universal. I'm going to remove this guy. That's all I'm going to show you in the manifest. That's basically only the new pieces. As Jason had pointed out before, it's an AppX. This is more evolution and us layering new features. So I have my project, my Universal Windows application. We took a look at the manifest. Why don't we actually take a look at building and packaging? So if you're a mobile dev or Windows mobile dev, you might notice there's a difference when you actually move to AppXs. AppXs have distinct verbs. I can build, and then I can package. Whereas for Silverlight Zaps, basically we put it into the same build verb. So you'll build, you'll F5. When you F5, that requires that tooling integration I talked about before. You really need to enable developer mode, not just side load, for that to actually work. The real difference here is that when you F5, we're doing what we call a loose file deployment. And the reason why we do this is for the REPL loop, to keep it efficient. We don't want to package up and send the whole package over every time you hit F5. So we do a loose file deployment. We basically update the files that have changed and then actually start the debugger again for you. So when you're under F5 or you're in the IDE and control F5, you're actually not deploying from package, you're just doing loose file deployment. So anything that's related to packaging related features like incremental download or anything that's associated with the app footprint, you're not going to see that at F5 time. That's basically the whole enchilada. If I want to package this thing, I right-click, I go to Store, and I'm going to create app packages. You're going to get this dialog. It says, do you want to build one for the store, or do you want to build one for local, right? There's a couple of different additional work that we do when we're going to the store or when we're going local. But for the sake of our demo here, I'm just going to create it local. So on this dialog, you're basically it's going to define the output location, and it's going to want to bump the version. So as Jason mentioned before, we have formal versioning. This is something we didn't have in Silverlight, and it was somewhat of a problem. Without formal versioning, in Silverlight, you could just put foo in there, whatever. It was basically developer defined. The problem with that is that we could get into cases that in certain siloed scenarios or whatnot, we could down level an application. And that's typically never really what you intend to do. So when we go to deploy, we always check the version numbers of the packages. So VS is going to offer to increment it for you. And if you want to generate an app bundle, the app bundle is what Jason was mentioning before, where we can have, it's a packages of packages that are applicable to certain class of devices or DX levels, screen sizes, and so on. In this dialog, you can define the architectures you're going to create. Now, if you attended our session last year, basically what you saw at Visual Studio is that the artifacts were the same, the manifest, the universal app, the manifest was the same other than the version number, but it was a kind of a project with an integrated environment, but it was two heads, which it enabled you to share a lot of code between desktop and phone. Now with 10, you can actually share binaries, the same binaries, it's the same app. And you can actually even create a bundle that has all the architectures you want to support. So you're not schlepping like 4 different packages up to the store, you're just submitting one, and you can version it as one. And within that are packages that are applicable to architectures and so on, and those have version numbers too. For the sake of the demo, though, I'm just going to actually build individual packages. Okay, it's going. Okay. Okay, so I'll put my packages here. So for desktop, you can run Elevated, you can do lots of different things, right? And the tools pretty much effectively run full trust, right? And when we produce packages, we do things like we produce a nice little script that you can actually run to deploy it. And of course, we've already enabled dev mode, and it deployed my application, right? If you want to see it, it is here. It just got deployed. Now for phone, for mobile, we don't have that model. Nothing runs full trust. Everything runs in what we call a low box. So even the developer tooling, where it actually integrates, it runs inside of a container, and we only allow the developer tooling what it's allowed to actually do on the platform. This prevents somebody using tools against the device to attack your apps, or as a user to attack your information and whatnot. So effectively, it runs in what we call a low box. So the way that you actually deploy is you have to deploy through agents and tools that actually bootstrap packages over to the device and actually will start them. To deploy this on mobile, I think the way I'm going to do this, I'm not going to use the overhead projector. I'm actually just going to if Windows will let me. So I have a screen mirror. What I have here in my hand is basically a Lumia 630. I'm going to say allow it to project my screen. It wants to behave. Oh, it quit. Okay, let's try that again. There it is. So basically, I want to enable side loading on this because I'm not actually going to F5 the application. I'm just going to deploy it from package. So I'm going to go through the same CPL, same control panel for developers, and I'm going to enable it. Now, due to an unfortunate bug, and probably why you guys aren't getting this feature, I actually need to do developer mode for now. But let's make believe we didn't see that. If you only need to sideload a package, you just need to enable sideloading. Now, for this case of it, I have it actually enabled. We have a new command line tool, like we've shipped previously, that it only deals with UWAs, or Universal Windows Applications. So the old tools, apt deploy command, dealt with 8.1 packages, and then we actually had to deploy utility for 8.0 packages and so on. But this deployment tool basically are targeting devices that are locked. It deploys agents and whatnot. The way you actually do this, it's installed with the SDK. I've enabled it for deployment. My packages are here. I'm going to go back to the ARM package because I didn't do a bundle, I did individuals. And I'm just going to copy the path. Make sure I copied it. Open a VS command prompt. Oh. Why don't we try that again? Okay. This is the ARM. So basically, what I'm going to do is win apt deploy command. And the first thing I'm going to do is I'm going to give it the verb I want to install, right? And then I want to tell it where the file is, which the file should be that guy, the debug version of my ARM package. And then I need to give it an IP address. The reason why I give it an IP address is because we're enabling a very sought-after feature. We're enabling remote deployment. I'm not able to demo it today, but basically you can go through a pairing sequence with a host to pair a device. So you can imagine a HoloLens or a phone or a tablet or something that you want to enable and pair with your developer machine or an Xbox and just basically be able to deploy with it to it without having to tether it to your machine. Maybe you have 4 or 5 phones. And you just basically want to deploy your application to those different phones and see how they run on each one. It's interesting, one of the features that it actually has, it enumerates phones on the subnet that you're on. It's interesting at work, you run that thing, you're going to be sitting there for a while, it just keeps going and going and going. But when you're tethered to the device, it's basically the local IP. Make sure that this guy is on. Okay, so I'm going to go ahead and deploy it. I thought I might hit that. Let me tether and untether it. Okay, so it's deploying it to the device. And one thing you might notice, even though I had a C# application that deployed the .NET framework. So every application now, not just native and WinJS, they all have a framework package now, which is good because you get the space savings on a low-end device. So this guy should deploy. Okay, so it's succeeded. So you can imagine in an environment, you might actually have assigned IP addresses to a couple of devices. And you might have a build lab environment where you configure devices and you say, a part of my nightlies, I'm just going to just go through and deploy our app to it. And this allows me in the morning just to grab the devices, run through some scenarios, or run coded UI test on it to actually see how the app is doing. So my app is there. It's basically the same app that I have on desktop running on this device, compiled for ARM. Actually, I can touch the screen. And this is the same app here running on desktop. So this is quite a bit of difference from what we actually had last time around, is that we always had distinct packages regardless if you were going to do a bundle or not. And it's actually the binaries inside the package were not They were close to being the binaries. You were actually compiled showing quite a bit of this code, but these are the same binaries across device categories. Of course, they're always applicable to the architecture that you're running. But that's basically the demo of actually how you sideload now. So does folks think that that's an improvement to unlock the device from what you actually had to do before? Yeah? I see some nodding heads out there. OK. So I'm going to switch back to the deck. And I think Jason's up on storage improvements.
Thanks, Barclay. So that was a good talk. So one of the things that we've heard a lot from the keynotes and all throughout the day yesterday and today is that Windows 10 is targeting devices that are basically anywhere ranging from like the most powerful to the smallest, and that includes devices that have extremely low storage. And so one of the things that we thought about for Windows 10 is kind of along the lines of the space-saving improvements that we'd formerly done for Universal Windows apps. So we said, hey, we really want to make it possible on these low storage devices to have a first-class experience. And everyone has we see a lot of these types of devices that are like I have a Dell Venue 8 Pro right here. It's a great device. And with these types of devices that are 32 or 16 gigs storage, you install Windows, you load up some pictures, your documents, a few files that you care about. By the time you know it, you have no more room for apps, and then you're like, and I have to go and I have to erase stuff, I have to move things around, you got to shuffle, you got to do whatever you got to do to be able to install your apps, and that's kind of frustrating. And so kind of on the theme of storage improvements, we have a feature that we originally introduced in Windows Phone 8.1 that we're bringing finally to desktop here for Windows 10, and that's being able to install your Universal Windows apps to external media. And this is a really cool feature. I'm very, very proud of it. I'm really, really excited that we were able to get everything kind of slightly working for the demo here today. Unfortunately, the build, caveat to what Barclay said, the build that you guys have that's going to be released supports some scenarios. I would go and I would try it, but we should expect that there are a few bugs here and there and that there's some rough edges that we're still working through. So there's really two things that we've done for this category of storage improvements. The first one is this kind of apps on external media. And the big question that we immediately get is, well, I'm a developer, and does that mean users can pull out SD cards or USB drives and they can throw them in some other computer and look at the information on those files? The answer is no. So for external media, we went ahead and we really made sure that the data there is encrypted, the app data and the app payload is encrypted. So tampering becomes a little bit more difficult, and if files do get tampered, then worst case, app crashes when it runs, but there's no integrity loss or there's no kind of data or IP theft or anything like that. And that's actually pretty cool, and I'm going to go ahead and demo that a little bit later. The next storage improvements enhancement that we've created is this shared publisher application data kind of cache. And so I use the word cache there because it's something that we expect all developers that have multiple apps to use. And it's a data store that basically can be shared across apps that are within the same publisher. So the canonical example that we have is, say you have an application that requires some type of authentication, and you download, say, a user profile or some credentials or something that you want to share in between your apps. The good news is now you only need to do that operation one time. Any other application that gets installed by your publisher has access to that data. Previously, you were able to do the same thing via the internet. You could just send information up, and then that information can come down through the other app, or you store it on your back end, et cetera. Here, we've just made it easier to do, and I'm going to actually do a code demo in a little bit here as soon as we get through the apps on other media demo. So without further ado, I did want to go ahead and demo on my device. Now, again, caveat is that this device is it's a very, very close build, but we weren't able to get everything working on the official build. So we have, and Barclay, if you can switch to that guy. If you guys can all see the device here. So very familiar. What you're going to do is, to start off with, is that we've introduced this new CPL in settings. It's called storage. And this is from the phone. Anyone who's used a Windows phone, this will look very familiar.
Put this on this because you can't really see it.
OK, thanks.
There you go. Is that better? There you go.
That's good. All right. And so, like very similar to Windows Phone, you'll have how much space is available on each drive. I have a SD card here that's a 16 gig SD card. And just like you would be able to on phone, you can set the install to location from this PC or a different volume. Now, as you'd expect, if you have multiple drives plugged in, each one would be available for you to install apps on. Now, the key thing here is that, very similar to phone, is that a drive can only be paired to a single device. Meaning if you have, for example, two Windows 10 devices that you want to install apps to external media, this device can only be paired to one. You can't move it between all the other devices. And kind of going back to the encryption story, the data and the apps that are encrypted, the encryption is done at a hardware device and app level. And so what that means is apps can't look at each other's data, and then devices can't look at each other's data. So this way we keep the applications that were intended for a particular device for that device itself. And so we've already got the apps stored here. And so what I'm going to do is I'm actually going to go to the store. I have this app. It's called Dictio. It's a speech kind of analysis app. It's by Microsoft. And I'm basically going to install it. Now, the Wi-Fi has been a little bit spotty, so I'm just going to kind of kick it off, and I'm going to let it go. Now, the way that you can see kind of what apps are on your device is by going kind of digging a step further in through the CPL. And you have this, although it's not really clear here, you have this checkbox, and you can choose which one you want. And so for now, let's go ahead and I've already got some apps kind of preloaded on the device. Oops, there we go. So I have Link, I have this Windows Phone app, and I have my own plug. It's called Gizmo. And so what I'm going to do is we have options from here where if you click on one, you can tap, you can move it, or you can uninstall it. So that's available for all these apps. One quick note is similar to Windows Phone, pre-installed apps or the provisioned apps, the things that come with the device, such as, for example, mail or calendar or any like the weather or anything like that, those apps are not able to move. We've done that because we want to preserve the experience of the device in case that SD card becomes ejected. We want to make sure that other users, if they come and they log into the device, still get that first-class experience and don't have to go and re-download all those apps again. And so the app just popped up down there. That's cool. So let's go ahead and actually launch one of these apps, if I can get to it. Come on. There we go.
You're holding it wrong.
I know. So here is the Windows Phone app. Actually, let me launch this one too. And this is a FAT32-based SD card that we're running on, and everything is encrypted. And then I will launch. I also got Link, although I haven't signed in yet. I was having problems signing in. And so we have all the apps here. Everything's running. All these apps, everything works fine. And then the next question is, okay, well, now I want to move stuff back and forth. And so, again, to do that, it's very, very simple. You just simply tap. You hit move. You choose your target. Again, if you had multiple external drives or external volumes, you'd be able to select the one that you want to move to. And let's go ahead and hit move. And this will go ahead and it'll start the move operation. And basically, as soon as this move operation completes, so the app just got killed there, which is what I expected. And once the move operation completes, that'll vanish, and then you'll be able to access that app again from the CPL, but on the PC side. So it'll be in here somewhere as soon as this, or maybe it doesn't refresh. Oh, there it is. So that's that demo, and again, we've done a lot of work to get this working on the build as far as today, and although the option is available, we encourage everyone to go out and use it, and please let us know how you like it. There are some bugs, like I've said before. I've seen some myself, and so we hope that everyone's able to kind of enjoy that feature. So the next demo that I actually wanted to go through, got the clicker here, is the shared publisher application data, and this is kind of the cache, and that's a very cute picture, so let's go ahead.
Okay.
And I'm number 7, I think.
You're number 7. Okay, gotcha.
Or no, that's that guy. I'm number 3.
Okay.
So can everyone see my screen? Great. All right. So what I've got here is basically just a blank application. I haven't added anything to it. I've simply just created it because Visual Studio has been a little slow on my machine. So what I'm going to do is I'm going to show you what we're going to end up with, is that I have this app, And basically all this app does is it goes and it can save, it can load, or it can clear the files that are in the cache. And I basically have a text box here. I can type whatever I want, and then I can save that data, and then I can load it subsequently from any other application. So we're going to go ahead and build that app. And I've done a little bit of the work ahead of time, just to snippets to save time, because you guys don't want to watch me code up here on stage. The very first thing that we all need to do is basically to add the declaration to the manifest. Again, we go back to this manifest. The way that we declare we want to use this publisher cache folder is by adding a new extension of category windows.publisher cache folders. And so in this extension declaration, you can basically specify how many folders you want, and you specify the name of those folders. And so here I've specified the name as my shared folder, and we're going to have to remember this for later, because we're actually going to use this in code. So the second thing that we're going to do is, in the XAML, I actually just kind of pre-cooked all the XAML, and really all this has is very similar to this application. It's just got the 3 buttons and then the text box that I can write into. And now this is where everything gets interesting. So I have, the first thing I'm going to do is, since we're going to be dealing a lot with storage, we need to use the storage namespace. And then I've got the, oops. I've got the code set up just like all the blank headers for the buttons created. And so we have the three operations: the save data, the load data, and the clear files functions. And so I'm going to go ahead and implement those right now. So the first thing I'm going to do is I'm going to go and basically storage folder. I'm going to get the storage folder. I'm just going to call this shared folder. And then I'm going to basically go from the application data object, get the current, and then I'm going to get publisher folder. And then basically I already have the shared folder name, so I'm just going to use that guy. Then the next thing I'm going to do is I'm going to create a storage file. I'm going to, let's go to the shared file. I'm going to await, and then I'm going to say shared folder, oops, dot create file, and I'm going to give it a name, which is shared file name, and then I'm going to say, whoops, and then I'm going to just open if exists. I've had some bugs where I'm not able to, it like starts crashing. All right, so let's await, and we'll say, actually, you know what? Let me save you guys from my poor coding skills. And there we go. This is what it looks like. So basically, I create the storage folder. I grab the shared folder name. I create a file, and then I basically just write the file information out to that file from whatever is in the text box. Very similarly, I would do the same thing for the load folder, or the load data button. Basically, I read out from the cache folder, and let me actually make sure that you guys can see this. Let me kill this guy here. And again, it's very similar, but the one thing to note is that this is a cache again. And so the plan was, and I'm not sure if it's implemented yet in the CPL in the storage sense, or sorry, in the settings CPL, is that we want to give users the ability to basically clean up this data whenever possible. So at any point, the data could become deleted. And so we encourage you, if you plan on using this, just know that it could be removed at any time. And the last one is about clearing the files. And so here, basically, all we're doing is we're invoking this function that does all the hard work for us. And this basically just clears all the information in that cache. Lastly, I'm just setting the text box to empty. So let's run this. And I've got this guy open, so we'll put this over here. And it's going, and there it goes. So as you'd expect, I'd be able to type in, actually, let me just make sure that there's nothing there resident, because I've been testing this a little bit today. So I'll type in, here is my test message, and then I'll say it's 4:24 p.m. And I can save that, and from here I should be able to load it. Great, and then I can say here is an update to this message. I can save this again, and then I can load it again from here. And so this is a very simple example, but it's just an illustration of kind of the idea that you can, from with separate apps, you can actually have this common folder that you can share information in between. So again, as opposed to going up through the web and having to do all this HTTP requesting and saving things to your backend and then having to query down from the other app, we've given you a way to do that locally, and that's kind of actually pretty cool. And so I think we can go back to the slide deck.
Okay.
And with that, I'll hand it back off to Barclay for continued support.
All right. So we're on the home stretch. Just a couple more things to cover here. Like I talked about before, all previous package versions are still supported, so all the apps that you have in the store, there are no breaking changes in that term. We still support those packages in the store for all Win 10 family devices. AppX continues to be our path forward. I don't know if everybody caught the session. I think there's a session from guys from my team that are talking about the store Win32 story right now, and that's how it's going to use AppX packaging as well to be able to install desktop and .NET Win32 applications from the store. That is our investment path forward. It provides us a lot of the benefits that you learned about today. This is quite an eye chart. I always choose to show this because we cover a lot of information. It's around what version I pick of the packaging technology. What do I get? I'm only going to focus really on the right-hand column. So with 10, AppX version 10, you get this new device family targeting capability that we covered earlier. That wasn't available before. That's going to allow you to take advantage of features much more quickly as we ship them. Encryption, AppX packages are still not encrypted. Only Zap packages on mobile are encrypted. We haven't been able to pull that one off yet. AppX bundles, that's specific to the AppX technology. So if you want to actually bundle apps and only have resources that are applicable to the device, pull down from the store, that's really tied to the AppX packaging technology. Debug package signing, why I'm throwing this out here, all packages are now signed. There was a difference back on mobile in 8.1 is that local dev packages aren't signed, but now all packages are signed to actually kind of assert the identity of where that package actually comes from. And the differential download update, what you actually saw that Jason walked you through, that's also you only get that in AppX. That's really enabled through lots of plumbing that's in the OS and up through the store, actually how that actually all comes together, but it's heavily reliant on the package format as well. The file single instancing, that's across all Windows 10 device families now. It's applicable when you're using AppX package. External volume SD is in 8.1 mobile. We had this, we introduced it on 8.1 mobile, and it's have gotten quite a bit of use, as you can imagine. We've shipped a lot of devices that actually have constrained storage, so we actually looked at taking this to desktop now, not necessarily for desktop like these laptops we're demoing on, but this Dell Venue Pro, we're seeing devices go into the market that you can't install very many apps, so this is really expand the storage on that. And the shared publisher storage, that's new for 10, as Jason kind of walked you through. That's a huge benefit. That's a very highly requested feature over the years. We're finally able to pull that off. We have what we call an alias in our email address, this askapx@microsoft.com. That actually comes to me and my family, my crew.
Other family.
You guys almost feel like family in a bad way. We're running tight on time. We're probably not going to have a whole lot of time for questions, but we will be over at the expert zone right after this, so you can stop by and ask us questions. I think you're going to the insiders.
Yeah, so I'll be in the insider lounge, which is I think across the street from the Windows expert zone.
You guys come to see me. Okay, so some related session. I'm going to walk you through all of these, but if you're interested in actually how this actually works end to end, I actually pulled together a number of related sessions you should go check out. Some of them have actually already occurred, and so you'll have to watch the recorded ones. A couple of more that are going to happen tonight is that the deep dive on publishing universal Windows apps, that's actually tonight. John from my team, he's actually covering all the enterprise goodness around deployment, and that's next week at Ignite. If you're in Chicago, go check it out. If not, watch it online. And again, please fill out a feedback. Let us know what you liked, what you didn't like, what you really wish we would have covered but didn't. But thanks again for showing up. Thanks, guys.
Thank you.